Hello everyone, my name is Kunal Chopra and today I will be talking about my A4 project for my robotics engineering class. Before we get into it, I'll tell you something about me and why I have taken this course. I am a huge hockey fan and love playing hockey, but on the other hand I love to make, fix and sometimes break stuff that requires screws, wires and motors. The main reason why I have taken this course is because I want to learn and pursue engineering skills as my career. Now, let's get into this project. So over here, this is the list of the hardware required items. First off, there is the container, which is the chassis, the breadboard, the USB cable, a cell holder, battery snap, cells, motors, wheels, switch, motor controller, motor shield, and the potentiometers. Moving on, the two major aspects of this project are accuracy and precision. For accuracy, our bot had to be judged by how straight it proceeded the 10 feet distance. For example, if my robot hit the center by going in a straight line, then my robot is accurate. For precision, it means that our robot may not hit the center, however, after multiple tries, the robot will end up in the same spot or near it. For example, if my robot is always 10 inches away from the center, then it is precise. Now before we see my robot in action, I would like to talk about some pros and cons. So the pros, I didn't get such a bad robot, but it still needed some improvement. There were not much changes or additions that I need to do for this robot. Now the cons, the potentiometers were really hard to control and turn to the right spot. Also, the friction between the wheels and the container gave a lot of up and downs in the data. This is the way I have scored my robot's path from the starting point, crossing the 10 feet mark. Then wherever your robot lands, that will be the score. If your robot is in the positive number zone, then it is going to the left. But if your robot is in the negative zone, then it is going to the right. The difference between each marked score is 7 inches. Moving forward, this is my data that I have collected after trial and errors for each controlling, programming, and electrical method. So for the first controlling method, the average that I have got is 3.5. Next, in my programming method, my average that I got is 1, which makes it 7 inches away from the center. Lastly, in the electrical method, by the use of potentiometers, the average that I've got is negative 0.8. Also, the electrical method was the best method for me because it was accurate and precise. Going back to my data points, I have at least 8 points that hit 0 and 2 other that were kind of off. But this shows that my robot is precise and accurate. The way I have wired my robot is shown in these two fitting diagrams. The programming and mechanical method are wired the same way, but the electrical method is different because we connect in the potentiometers with the motors to control them. Observation. After many trials, coding and corrections, I can say that this robot is the best it can be. In the mechanical correction state, I first carved out the container's motor hole so that when the wheels rotated, it won't slow the speed down. Also, I electrical taped the container to squeeze it in and somewhat change the shape of the container from a trapezoid to a rectangle because the wheels were rubbing against the container, creating friction. Next, the program balancing state, I just started to change the speed in the code, and after many trial and errors, the speed of the blue wheel was decreased by 19. After this, it was time for the electrical correction state. It was quite easy to figure out how to place the potentiometers. Once they were connected, it was hard to get right turn and how much to turn because of the limited amount of rotation it had. After many turnings, I found the best speed and it was accurate and precise, making the electrical correction state the best method of balancing. Finally, to improve on my robot, I would rewire my bot so that it is needed. Also, I would add a LED so that I can know if my bot is on or off. And lastly, I would try to figure out any other irregularities other than the wheels touching the container creating friction or the back of the wheel rubbing against the ground creating friction. Thank you for watching.